Hello, everyone. Welcome to Pivot 0x Hub Masterclass. My name is Shantanu Sharma, and I head the operations at Pivot. For all those who do not know about us, Pivot is a global Web3 startup accelerator, venture accelerator firm. We mostly focus on accelerating early stage startups in this space. I invite you all to follow us on our social media channels to know us more. I will share the social media links later in the chat as well, so that you can, pursue and go over there. As far as Zero X Hub is concerned, we are an open masterclass initiative. We have started this primarily to enable Web3 startups and aspiring founders with knowledge from within the industry. It's not meant only for the startups that we accelerate, it's for everybody in the field. And all our sessions are being led by experts in the field. And there are people like founders, investors, angels, and many more. We've already done about nine of masterclasses now. This is the 10th masterclass. And we will do at least two or four every month on multiple different topics, related to technology, Web3 sectors, products, goals, leadership, and everything that can help startups grow. Okay. So we have started this new series of masterclass called Build with Founders, in which we will bring young founders from the startups that we are working with right now or accelerating, and they will come and talk about the product that they're building, the problems that they're facing, and how the challenges that they're facing and how they're solving it, and what they're building on, and also point out how it can benefit the Web3 space as well. Today, it is my pleasure to invite my good friend Hitat Jain. He's the co-founder and CBO at Cluster Protocol, sorry. And it's a brilliant startup, that we're working with. And my association with YJ goes back at least 2.5 years now, YJ, when we
Yeah,
started off in supporting various projects in the space. Yeah,
yeah. So
yeah.
yeah, like
Very, very,
I have been
very
knowing
happy to see you. Yeah, yeah,
I've been knowing Shantanu since a while, right?
yeah, yeah, yeah.
I've been working around in the space in a couple of projects, and it's an honor like to have this masterclass. Also, like would love like if you guys are there, if you can turn on your cameras, and then it would be a more of a interactive session
Yeah,
that I would love to do.
great.
So
Yeah,
if you
yeah. I'm
comfortable.
very happy, Vijay, to see you, building, an amazing product in the AI and deepin sector. But I think I will leave the entire introduction to your product, everything to you as well. So please, all over to you now. Please continue.
Yeah,
Yeah.
for sure, for sure. So yeah, like it's just one request from all the participants who are there. If you can turn on your cameras, we would love to interact around in the session, and it would be a more fun session for you guys. But yeah, I got the PPT ready. Shantru just gave me a heads up if the PPT is still visible.
Yeah, it's visible. You can go ahead now, please. Yeah.
Cool. So yeah, let's get started with it. This is YJ, aka Deep and Daddy. Deep and Daddy is my pen name, or you can find me anywhere over Twitter, LinkedIn, Telegram, over at Deep and Daddy, DEPINDAWY. So today, I would love to explain you guys a little bit more about how these LLMs work, right? And what are these params? Params are nothing but parameters to these LLMs. So first of all, you need to understand what LLM is. If you'll break down what LLM is nothing but large language model. Okay, so there is a Python code, right, on which you train an AI model on large loads and loads of data, right? And then, like for a layman, I'll just go with the terminologies and with the explanations for someone who is like who is non-techie as well to understand it, right? So I'll not get much more into detail in terms of technicalities of stuff in the beginning, so that people are able to catch up with me, or the people who are new in the space are able to catch things around, and then we can go more into it as we move towards the end of this session, this masterclass. I'll also have an open stage for you all for question answers, for interaction, and for many more stuff we can have for that. So delve deeper into the topic. So LLM params, the secret sort of source of AI magic. But before that, who is YJ? Right. So as Shantanu has already introduced me, I'm co-founder to Cluster Protocol. Before Cluster Protocol, I have been working around with various tier one projects. I have experience in business development. I have helped scaling brands with partnerships and collaborations. Some of the major brands include Router Protocol and a couple of other tier one projects. I was also ex-CMO to Lunatic Games, and I'm a skilled growth marketer. I've scaled communities for various Web3 projects, including Push Protocol, including there are a couple of other projects as well, which I have helped them around. Now, moving ahead, I would love you to explain you guys about what we at Cluster are doing, right? So you, if in case you might have heard about us, it's good. If in case you have not, then I'm here to explain you guys a little bit about what we guys are doing. So we are building a decentralized infra for AI, and we aim to achieve the GitHub for AI models. So what you can have on Glassdoor is you can have plug and play AI models. There's a big data marketplace which you can access. There's a collaboration hub where you can build your own agents. There's a template library where you can just plug and play templates and you can build your own AI creation. And we also have enterprise grade of GPU compute. So these are the five major things, or five major uh, facilities that Cluster provides. And in short, we are providing an holistic playground, a kind of a more open playground for users to build their AI creations. And their AI creations could be anything. It could be as small as tweaking a prompt and building a solution on top of it, and it could be as big as building their own AI model and then leveraging compute and data set from our platform to build their own AI whatever solution they want to build. So everything is possible on top of our platform. Our platform is modular enough, and you can just pick the parts that is missing from your AI cookbook, right? So to explain more into detail about this, so you need three things to build any AI solution. Okay, ChatGPT also needed these three things only. You name any of the LLM model or any of the AI project, AI startup AI solution that you see in this industry, they just needed three things. First is compute. What is compute? Compute is nothing but this graphic processing unit, or these CPUs which is there in your computers. That is compute. Now the difference between CPU and GPU is a thin layer of understanding it in a way that if in case you want to do more complex tasks, right? If in case you want to do if you in case you want to do training at a higher pace or at a higher rate, right, then you would be requiring GPU, or else you can achieve basic tasks over CPU as well. We got NK opened his camera, but yeah, he went again, he went off again. So yeah, now coming to the second thing that some AI startup needs is or an AI solution need is data. So now what data means is you need a structured format of data that is known as data set, which you will give it to that AI model. AI model is nothing but a Python code, right? On this Python code, you will fuel this with a data. You will have algorithms written in this Python code. There would be a big code which would be used for training that AI model, and then you would be needing compute as well to have this training occur after and after and after and after. After you have trained your AI model, what you need is to do the inference. After the training is done, inference part will take place where, okay, what happens in training? There are multiple methods of doing the training. Okay, let's take the very simplest method where, okay, there is the data that is there, and then there are the questions that are there. Okay, so we were trying to decode how an AI solution is made. And with that being said, we need three things. Okay. And after this is done, inference would take place. Inference is nothing but uh, the model will answer like in training. Let's take the, yeah, we were on the training part. Okay. In training, let's take the simplest example of training where there is data and there are questions. You have mapped those questions around, and the model is answering based on the data that is known to them. Okay, now let's say in the inference part, the model is thrown out for testing. So it's kind of a beta, like you can understand it for a layman, you can understand it that in a way that it is a beta testing for a user, like just how a product is beta tested by users. It's the same way inference as well. It's just pushed out, and it's just like it could be pushed out publicly, or else you can do private inference as well. And you just type off the questions, and then the model answers them based on the knowledge they have acquired, or based on the training that they have done, right? So as I have explained you these three things, cluster protocol makes you available all these three things: the data sets, the compute, the AI models. On top of that, we are also having a modular framework to make AI agents, right? Now, after you have built these, or you have a successful model running, right? All these open source models, these Llama 2, these Mistral, and all these other models which are open source, right? On these, you can build micro niche utility AI solutions, which could be known as AI agents. These are the AI agents, right? An agent could be like an example of agent could be, so if you have seen these small tools, copy.ai, Jasper AI, these other agents, like there are multiple crypto agents as well which are there. There was this project known as Octavia, which was getting more into the crypto trading part, right? And then there are a couple of other agentic solutions which are available. So what we are providing is we are providing the core solution for anyone to hop onto our platform and to build these AI agents. And this is what cluster is all about. And that is why we say that we are trying to achieve and we are trying to build the GitHub for AI models, right? So let's move ahead. Now, as I already told you, that there's a meme that my intern had put in this PPT, that says that I want to train an AI. You mean fine tuning an AI? Fine tune, right? So there's a difference between how you actually fine tune an AI, or you just play around with the parameters and uh, get your desired solution achieved, right? Actual fine tuning, as I have already explained you previously, states that you take the data sets, you have the base model, you infuse the data set, you have to compute, and after combining all of that, training would happen. And this is how you are able to fine tune your AI model. But alongside that, what you can also achieve is you can play around with the parameters, like you have OpenAI's playground. If you'll go to replicate, if you'll also come to our arena as well, you'll find that you can just plug and play around with a couple of parameters, and you can achieve what you are looking to achieve without just wasting hours and hours and hours of actual fine tuning the model. But there are consequences as well. There's a disclaimer, which if in case you are able, like if in case you are doing it on prompt level, then there are chances that it will not give as much efficiency, and it might not be as reliable solution as possible, right? So it's well said. If in case you guys know Hindi, so if someone says that, okay, I'm doing prompt engineering, so that is somewhat of equally of saying, uh, it is the similar way of saying that अगर वो चला तो ठीक है, अगर चला तो चांद तक, नहीं तो रात तक, right? So yeah, moving ahead, let's get straight into what we are looking to explore. So today we'll understand just two topics. First things first, it's understanding the ingredients of LLMs, which I guess I have already explained you. I'll now delve more deeper into how an actual LLM works, right? How it works after the training is done, how it actually works, and then mastering the art of parameter control. So these are the two major point of topics that we will be exploring around. So let's delve deeper into understanding the ingredients of LLMs. So yeah, first of all, we need to understand these LLMs. You need to understand how the working of an LLM is, right? An LLM doesn't have its own memory. An LLM is not something which is having a neural network, an LLM is not a human, right? You need to understand it's a computer program only. Now, how this LLM works is very interesting. Okay, it all works on the game of probability. How it works is you have an LLM. Now you have input a question, right? And question could be anything. Let's say you have input a question, hello, how are you? And it's a fine-tuned LLM, let's say it's a fine-tuned solution, AI solution, which knows that my name is Yatharth and I am co-founder to Classroom. Okay. So now what you are doing is, first of all, you have fine-tuned that solution, fine-tuned that AI LLM. Okay. And now when you have put that, hi, how are you? Now there are two things available, or there are two solutions available. First things first, if you will type it in a general chat, GPT chat, or in any of the other solutions, it will give you an output as, hello, I'm fine, how about you? And then here, it just works on characters. After it has generated hello, right? It will figure out and it will find the probability of the very next word which it could output. And this is how a simple algorithm or a logic of an LLM works, right? If you'll fine tune it, you are restricting it off. So if you are fine tuning it, and or if you are making him understand, or if you are making the context clear that, okay, I am Yatharth, I'm the co-founder of Classroom Protocol, and you need to remember this off, right? There is a feature of memory as well. If you'll see in modern solutions, be it Perplexity AI or even OpenAI, also provides this feature of having a memory where you can store certain instructions, and that this chat or all the chats will remember, or all the solution will remember, right? With that being said, what you can do is, so if you have fed in, okay, I'm Yatharth and I'm co-founder to Cluster Protocol, and if I'm typing, hi, how are you? So instead of generating a response of hello, I'm fine, how about you? It'll generate hello, Yatharth, right? So this second word, where in the first time it was a comma, now it comes out to be Yatharth. And why is it? Because it's all about the probability, and you have made the probability of Yatharth coming at the second spot very prominent by giving that instruction that, okay, I am Yatharth and I'm co-founder to I'm co-founder to Cluster Protocol, and you need to talk to me like that. You have given that instruction in the instruction tab of ChatGPT of F or any other LLM model, and that is how you are able to fine tune it on the surface level or on the prompt level, but that's not actual what do you say, fine tuning, right? Moving ahead, we need to understand the significance of parameters. For that, you need to understand that most of the solutions which are available around, that use prompt engineering to a very much extent, because it is very expensive to have your own AI model. It is very expensive to do the fine tuning. It is very expensive and compute intensive as well to have your own solution built from scratch on these base LLM models, right? It's very expensive. So for a newbie who is getting into the space or who is looking to build some solutions, and that is also where Cluster Protocol comes into picture, and it provides you the playground, which is just like cheap as possible, right? Yeah,
Yatharth,
it's a,
can I
here
ask a quick question, or is it okay to disturb in the middle?
you can surely ask it, like if in case you would have asked in the end, it would be good. But yeah, you can ask if you have unmuted your mic.
Yep, thank you so much. No, I was just asking, when you say very expensive, can you quantify that expense, so to speak,
So
versus the value
it's
that
just
you can
about
derive?
explaining, or it's just about assuming how big the task is. Say so like we can take example of our own labs. So Cluster Protocol has our own labs where uh, we just brainstorm the ideas and we just build AI solutions as well, or these AI agentic workflows as well. So one of the agentic workflows or AI suits that we're working upon is an intent based AI wallet. Okay. So that wallet can help you do whatever your MetaMask can do. On top of that, it has real time intelligence and it fetches real data from sources, and it gives you an output, and it also has analytical thinking to answer some questions like, okay, compare the TVL of all the layer one solutions, layer one blockchains, and then find the change from 2023 to 2024, and then give me top five protocols based on the TVL change, right? So it's a very big query. If in case you want to do it via prompt. You can achieve it by having if else loops, by having functions. But if you want to do it the right way, or I wouldn't say that it's a wrong way of just putting functions into picture or having it done over prompt or surface level. But I would say the actual way of answering such type of questions which a human can ask, and that there could be a variety of it, is by actually fine tuning it. And you would need compute. So if you'll see our compute bills for like months, like since months or months, it's more than like $5,000 anyway. It's more than $5,000. And it had even spiked to 10 to 12,000 dollars per month as well. So that's where the compute plays a crucial role there. And also in expense, there are two expenses. First is the time consumption, and second is the cost consumption, right? And in terms of cost consumption, you need to understand it in a way that if you have heard of Pi 3, which is Microsoft's latest offering, right? It was trained on, if I'm not wrong, if I read it right, 1000 H100s. That is not of PCLE, that is SMX quality of 80 gigabytes. And those were run 24/7 for 1 month, for 30 days. And that's how they were able to make this big of a model, or Pi 3, PHI 3, which they had done. So yeah, expense counts in terms of it could be quantified as in two terms. First is time and second is cost. I hope I'm able to answer you, NK. Okay, I'm not able to have any response from him. So yeah, moving ahead. So we were on the significance of parameters, right? So you need to understand. My screen sharing is paused. Okay, got it. Yeah. So you need to understand how these solutions works, and I hope I'm able to make you a basic gist of what all this is. And let's dive deeper into a couple of parameters to explore what is it. So this is the screenshot from our arena. You can check this out at arena.clusterprotocol.ai. This is MetaLlama Guard 2B. It's an LLM 3 based model for moderation and safeguarding language model. So what this model is used for is for it doesn't have explicit content, as well as it also safeguards a couple of things, right? It safeguards the model itself, and it doesn't exploit itself, and it's a kind of a compact model as compared to llama 3, right? So there are a couple of parameters you can check around. So in input you can have your prompt, right? What is your prompt? Your prompt is nothing but the prompt that you type in on the chat of any of the solution of any wherever whatsoever the AI solution that you are using. The your input prompt is the input prompt, or your prompt. Then comes the system prompt. What is the system prompt? This is very interesting. System prompt is nothing but the custom instructions that you give. Okay. So let's say you want to give the system prompt as, okay, you are an astronaut and talk to me like astronaut. You are Elon Musk and you are founders to SpaceX, you are founder to Tesla, you are this, you are that, this is blah, 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 blah. You are mathematician, you are Aryabhatta. And this is how the system prompts work. After you have set a system prompt, you can just input them anything, and then they will give you customized response based on that, right? Coming to the next params that we see here, that is max tokens and min tokens. This is very interesting concept of max tokens and min tokens. These are nothing but you could consider them as maximum limits of tokens could be generated. So to understand what tokens are, as I already explained you how these LLM works, right? It is the probability of figuring out the next word. Now, each character, so if there is hello, then H also have certain value, E also have L, L, and O, and all combining of them would also have certain token value. Okay, these token value, and it is not that okay if hello, let's say if hello is of two character, or if it's of two tokens, then let's say dictionary would be of more tokens, right? It depends, it is varied in nature. Approximately over like the approximately over all the in these extensive used LLMs, 100 characters will lead you to 40 tokens. So that's the conversion rate which is there. So 100 characters will lead you to 40 tokens, and thus you could have limit those max tokens. And with that being said, tokens are the combination of input and output. It doesn't, it is not like just it is which is in the input. So max token could be utilized. If you reduce the max tokens, what you can achieve is you can and say you have a very large input, okay, very, you have a very large prompt, okay, you could help it achieved via reducing the max tokens. The response that will come will have a limited set of tokens which it can utilize. Thus your response will be, would be very restricted and would be very small in nature. And similar thing goes for mint token. If you increase the size of mint tokens, right, then you can have much more bigger context window, much more, let's say if your output is very short, then you can have a very bigger output, right? So this is how the min and the max token work. I hope I'm able to make you understand. So max tokens are like, usually you cannot like you can increase the max tokens, but there's of no use of increasing it. You need to decrease and you need to compress it till the point, so that if in case you have very big output, you can have a restricted smaller out input, sorry, if you have a big input, you have a restricted smaller output. And for mint tokens, you can do it towards the maximum size of thing, so that if you have a very small input, you have a significant chunk of large output. Here a question could come into your mind. If in case say the output is not that big, what will happen? Okay, if the output is not that big in mint tokens, then what will happen? It is not like it will just add randomness into the answer, or it will not add randomness into the output. Rather it will just produce the suitable output as per the use. But if in case you are able to master the prompt, if you in case you are able to master the prompt very well, it can give you fabulous results based on adjusting these parameters. And these are the very elementary parameters, I would say, combined with top K, top P, and temperature can do wonders. These parameters alone, I don't think so they are much of use. But if you combine these with top K, top P, and there are a couple of other parameters as well, temperature, that way you will be able to achieve a better what do you say, a solution that you are obtaining for. So coming to the temperature, it sets the randomness of the model, okay. So if you have higher temperature, it is more random, and the model's outputs will be more creative and vivid in nature. If you restrict the temperature, it would be more focused on one thing. It would be having so it's the same way of saying, for a layman, it's the same way of saying that how creative you are, or how like if in case you're using your brain, how much you're using your brain to get the work done. So that's how the temperature param work there. Now comes top P and top K, okay. So top P is nuclear sampling, right? For nuclear sampling, it's nothing but restricting the words, the probability, right? Restricting the probability of words which people could use, right? So which we not which the LLM output would be given. Okay, that is nuclear sampling. So what you can do is, by reducing the nuclear sampling, as I explained you, the game of probability that happens in these model outputs in these LLMs. You need to understand it in a way that if you reduce it off, the probability of like you have reduced the probability of major of the things. Okay, you have reduced the probability. So when you are fine tuning it with say, let's say, if you are putting the system prompt as the person who is using this is Yatharth, and this is co-founder to Cluster Protocol, and you need to talk to him by addressing him, and you are reducing the top P parameter to a lot, then what will happen is you are anyways eliminating all the responses, all the generic responses which could come, and then you are making sure that hello ke baad, after hello, Yatharth should pop up in the output if someone is asking hello, how are you? Okay. Coming to the stop sequences are nothing but it's just that when are you urging the model to stop, right? So here it is written end of text and EOTID. So these are like commands which you can give. So end of text is after the text is ended, you need to stop it off, or else when the ID like EOTID is hit, you need to stop it off. Similarly, you can use many other stop sequences as well. These stop sequences are useful in jump queries. When you're looking to jump the queries, it is very useful in nature that way. Now, coming to like I have already explained your temperature control, top B sampling, and then yeah, like you can make the model creative enough by adjusting these parameters on the param by adjusting the params that I've already suggested you, like by increasing the minimum token sizes and then increasing temperature and all the other parameters which are there. So I guess that is also clear. Then coming to the seed and denoises steps. So these params are mostly used in image-based or video-based LLMs, stable diffusion. Uh, then there is other one, Bark, Suno.ai, and there are a couple of other. So what seed is nothing but you could understand. So before that, you also need to understand how these image-based LLMs work. Right now, I have explained you how text-to-text-based LLM work, but how these text-to-image-based LLM works. So let's say if you have typed in a query stable diffusion or mid journey, which says that okay, I want to make a portrait of a clown on horse. Okay, so what will happen is after that input is given, some noise would be there. You knowing about the images have noise, right? These noise grains, the video that is also that is there on your screen of me as well as of this presentation, this is also having noise grains, right? So some random noise is there which is produced, and based on the input you have provided, this noise will restructure them into that image. If you are a core enthusiast of these AI solutions, you might have seen right now the solutions are way more advanced and they are giving you more hyper realistic outputs in terms of images, and then there are a couple of others as well which are able to do it with video as well. But the major question comes into picture is how it is done, and this is how it is done. There is some random noise which is there, and based on the input that you have provided, it just restructure themselves to give you an output which might resemble, which might not resemble, but they're like now the solutions are far better than. So if in case say that the elementary models of stable diffusion were also not that great, which they are now, mid journey was also not that great. Right now what I'm seeing is the best models for image, right? I was trying this grok 2 which you get after subscribing to a premium of Twitter. It is very good, I would say. It is giving very realistic solutions, as well as uh, due to as it's not much complex in nature, you can have multiple things to be changed as well. And this is where the concept of seed comes into picture, right? So what seed is? Seed is nothing but let's say a serial number which helps you recognize the current state of noise production. Okay, so as I've explained you this some noise which is then combined together to build a clown on horse. Now you say that I want to use the same picture with the same blue background with the sun on the left, and now I want to put hat on the clown. How will you do that? You'll do that by having the seed set. If you have the seed for that image or for that noise production that is there on which you want to put a hat on the clown, you'll just use that seed. And then here as well, these params like top P, top K, and temperature comes into picture. You reduce them all so that the model doesn't think much, and you just write, okay, uh, put hat on the clown. And that is where you are able to achieve an image where now that noise production will again start the process, but now as it knows that it doesn't need to start from the scratch where there's some random noise, so they'll start from the noise which is already produced, and then they from there they'll understand and identify, okay, there's this clown, and on this clown I need to put the hat off. And where if in case you are able to adjust other parameters to a lower extent to reduce the variability, you are able to achieve your desired solution. And that is how seed works. Coming to denoising step explain, I denoising step explained. I've already explained you how these denoising works, right? So after noise is produced, then denoise helps, and these denoise takes place where each step is broken down, and then you get the final image. Then balancing the creativity and precision. So I guess all these parameters are also available on all of these stable diffusion mid journey and all of that. You can have a try over that as well. If in case you want to try open source models which are there, like, so there are 33 models which we will be like at the moment, which we are hosting over at Arena, which include variety of models from Salesforce, image captioning to SLDX and SL Turbo, like Stable Diffusion Turbo and Stable Diffusion, the base version of it. So, and there are a couple of other models as well. You can check us out as arena.clusterprotocol.ai, and you can even try these params out, and you can like work around and then test around and play it around over there as well for free. Now coming to the mastering the art of parameter control, right? So here there is frequency penalty, there's presence penalty, and then we will understand the impact of text generation over it. Now this game of penalty also comes into picture where there are parameters which are there based on which you can have the frequency penalty and the presence penalty. Let's move ahead and I'll explain you more in depth. So first of all, there's defining the system prompts. You have already defined a system prompt. Okay, you have already defined that. Okay, now say you are you are an astronaut, or you are a consultant for McKinsey, right? You are a consultant for McKinsey, and you are highly analytical in nature. You did your undergrads from IIT Bombay, you did your grads from Massachusetts, and now you are sitting on your desk and you need to act like you are working on your desk in McKinsey, right? Let's say this is a system prompt that you have given. Now you need to understand the prompt templates. Okay, after the prompt template is understood, you need to make sure to understand the way the system behaves. Frequency penalty is nothing but if you'll increase the frequency penalty, then the penalty would be more based on the frequency of words that is generated. Now there might be something which McKinsey consultants might repeat themselves again and again and again and again and again. If you reduce this frequency penalty, then what will happen is those words would be repeated again and again. What if you increase that penalty? Then you are able to be more creative and vivid in nature, where your McKinsey consultant is acting like a degen crypto trader. Maybe I'm not sure. You need to play around with it. Maybe I'm just saying, and he's using words like, I'm not sure about it, he's using some words which a McKinsey consultant on his payroll might not use. So that's how frequency penalty works. Then we have presence penalty, right? So for presence penalty, it's the same way of saying that uh, like it's kind of a way of saying that how present the model is, how present the model is, or you are like making the context very small or very big. If you're making the context very big, you will keep the presence penalty to be very high, because you need to make sure that it should have the presence and it should be able to understand it off, right? Then coming to the role of prompt templates plays a very crucial role. So rather than having these template, like having these prompts to be crafted, there are many solutions which are available. There's AI PRM, It's kind of a dashboard where you'll find multiple prompts, and there are a couple of other solutions as well where you can explore and have these prompt templates. So what these templates are having placeholders. Okay, these templates are having function calling. So what you can achieve over in less than no time, and as Enki said that how can we achieve these solutions at a lower cost, or how can we save the cost? We can save the cost by having functions, by having if else loops, by having Python loops, and having functions to it, and having calls to it, and then putting it over onto the what you say platform, or onto the uh, prompt, right? So there are two of them. First is function calling, second is what you say placeholders. So what placeholder is an interesting concept. So placeholder is nothing but of you saying that, okay, so you can put these smaller than and the greater than sign, and in that you can put any of the placeholders. So there are a couple of known placeholders, as all the LLMs use NLP. They understand basic placeholders as date, time, or any of the placeholder you want to put in. But you can have custom placeholders as well. So let's say you have a placeholder which states yatharth, and there's a function that just gives an output of 0 or 1. Okay, and what you can combine is you can call this function XYZ function into your prompt, and to check the output, and you just say, okay, the placeholder yatharth should return yes if the output that is coming from the function is 0, and it should return no if the output from the function is coming out to be 1, which is you are inversing or reciprocal, you're doing the reciprocal of it, inversing it, sorry. So this could be achieved over prompt level. You don't need to fine tune for such things. And like this is a very elementary example to it. You can achieve multiple things out of it, right? You can achieve multiple use cases out of it as well. And as far as I know, most of the, like, if you have heard of many solutions which are built are using prompt engineering itself. Like initially they started off with prompt engineering, and as they grew big, they then started having their own fine-tuned models over the stuff. As far as I know, all of these text-based, like these copywriting tools and all those stuff. So I know Right Sonic. So it's a Y Combinator backed uh, project, or a startup. So like founders, I know the founders very well there, and they have told me that most of these, what you say, most of these grammatical solving agents, or these copywriting agents, most of them are working on prompt engineering, and like 60% of them are using OpenAI. So if in case OpenAI shuts down, all these services, all these service based AI solutions will shut off, because they don't have any other option. They are exploring options, they are building their own solutions, but they don't have any option at the moment, right? So moving ahead, we have understood the impact of AI performance as well. Now what you can do is, yeah, you can have JSON files as well. You can like put the structured data in JSON files, and then you can feed this data. You can have system integrations, and this is where the concept of AI workflows comes into picture, right? So what an AI workflow is? AI workflow is nothing but you could imagine it as a Zapier integrated AI, something like make.com, like, or even better than that. So what we at Cluster are achieving the similar thing, where there are multiple AI agents, and then you can combine those agents and have intercommunication to it. So let's take a vivid example or wild example to it. Let's say there is a crypto agent which is like a intent-based wallet, which I have already explained to you what an intent-based wallet is. And let's say there's another fine-tuned AI model of Gary Kasparov, or there's a chess model which gives you moves, or which helps you play like Gary Kasparov. Now, let's say there's an Olympic game of Magnus Carlsen and some other competitor, and you are supporting Magnus Carlsen, and you have fed that AI agent that based on the real time feed of that chess match, play the next move, the very next move when the Magnus Carlsen's move come as Gary Kasparov, and it will play it. and the probability bar of winning, if the probability bar of Magnus is more than 70%, send 50 or buy me $50 of Ethereum, or buy me $50 of, say, a meme coin, right? A certain meme coin which is there, which is of Magnus Carlsen, right? Or maybe send $20 to some wallet. Maybe there are vivid examples of doing that. Also, all this, you want to do all this, for doing all this, you need a workflow. It can't be done with a single thing. You need two agents, you need a feed of chess, you need multiple things, you need a wallet, and there are a couple of other things. And this is what, if you combine all of them, that is what AI workflow is all about. So I guess, yeah, that's the very end of the thing. And I hope I'm able to explain you guys about these params, these parameters, and how the LLMs work, the magic of LLMs, how they are fundamentally built, and many more stuff. So yeah, with that being said, I hope now you are kind of an Sam Altman now. And yeah, these are like a couple of QR codes which you can scan around. If you want to reach Cloud9, then you can scan the very first QR code. If you want to connect with me, you can scan this cute little kitten.
Yes, sorry, I was muted
Yeah,
and
yeah,
not
yeah.
allowed to get muted. So thanks. This was really insightful presentation. Thank you so much. I was beginning to think we are the only one using AI and blockchain. So thank you so much. That what you describe makes sense, at least at the wallet level. One question I have is now that our models are becoming almost like edge computable, if I may. The latest one, the Llama 3.2, you could see it's. What's your take on basically, this parameter tuning? And again, my problem is largely on the cost. So we're avoiding the cost right now because we don't know what the cost is by putting RAG around the model. And we're building a almost like a global regulations on banking in an AI bot. So that's our current use case for our corporate customers. So we have enough data. All of that data is in one place now. We're trying to build a RAG around it. So if you have thoughts around, is that the right approach? Do you retrain the model? Do you tune the model, or do you fine tune the model as you called it? What's the right way of doing about it?
So if I've understood your question very well, so you are talking about edge computing, right? So if we are moving towards edge computing, it's the right approach to the future of AI. Is that your question is in summary?
Partially that, as well as partially tuning the model. So sorry, I kind of combined the two questions, but yeah.
Got it, got it. So coming to the edge computing part, it's good to see that, okay, imagine it in a way that, okay, so my mobile phones, my laptops, combining all of that together can work together seamlessly to have these models cooked around. But the major part or the major question comes into picture of, are they able to do it? Is your MacBook sufficient enough? Is your desktop sufficient enough? Because with that being said, you need these specific chips, or you need the hardware to be edge specific as well, so that you are able to achieve that, what you say, to achieve these claims over edge computing, the inference over edge computing. Inference could be done, inference is not an issue, but the actual training could be done over edge computing. And then if you want to take it to a decentralized approach where there's individual sources or individual computers, devices which are connected around, and then you need to achieve over that, I think it's feasible, it's possible, it reduces cost. But on the other hand, these chipsets are a scarcity, right? I don't find any solution at the moment where which your MacBook can support things of. Initial things could be supported. If you'll go to hyperspace, you'll find that you can have peer-to-peer compute, decentralized compute, which is there for AI inference. But when will the training part comes into picture? That's really a question. It's really a question. If you'll go to Cusco, you'll still find that you can run a basic node which can provide the compute, the RAM, CPU to the global decentralized infrastructure where people can do the inference. But the training is still a question there as well. That is where I think these edge solutions which are being built, it will take time. And after the efficiency and the major part that I find is something is of these chipsets itself. If you are able to produce those chipsets, and because these chipsets are expensive as well, like it is based on very low nanometer form, and it's not that easy to build them off, and that is why these chipsets are also hell expensive. So you need to make sure a balance of that as well. So if you're able, like if someone is able to do that, and if someone is able to have that hardware, then I guess yeah, they'll able to achieve that. Coming to the question of which is better, right? Fine tuning, or all this stuff. I would say you could imagine it in a way that if you are able to achieve, so as I already told you, with prompt engineering, you can achieve things of to a certain extent, right? And as those certain extents, there are possibilities of casualties. It is not a surety, it is not 100% surety that the model will give that output of the desired output that you are exploring around. That is also not sure of training on elementary level. You need to train it rigorously, you need to train it very well, and then you need to do on like in time inference, real time inference as well. And time after time after time after time, the more inference that is done, the model became better, right? And that's how it is done. So I would say for starters, for beginners who are looking around to get into the space, this is a tweak which many of the folks don't know about. And if people are able to figure out, so it's all about finding a product market fit. Okay, it's all about making your first $10,000 or having a revenue over that product. If you are able to have that, then you have $10,000 in your bank, and you can scale it off. You can like figure out more solutions with that money, and then you can scale it off to a certain extent. And I think that is my opinion over that. You can surely try these solutions off, try these parameterized fine tuning off. If you're able to achieve something, you put it out in the market, and the smallest cost, like it's a norm, like what's the smallest cost that any of the AI like AI solution can get? That is $20 per month, right? It's a standard set by most of these big giants. You can keep it less, but $20 per month is nothing that harms the pockets of users. And that's how Perplexity AI also introduced their things. So if you'll ask me personally, I don't use OpenAI more. I just use Perplexity AI. Like after this O1 has introduced, I just bought the subscription once again. But I was a vivid subscriber of OpenAI since its inception. Since its inception, I was a part of their beta test program as well, and I paid them every month reoccurringly, without even like there might be some moments where I'm not just using the model and still I'm paying them off. But when Perplexity AI came into the picture, it just changed the whole game, and now I shifted towards them, right? And also you need to understand there's this study as well. Most of the AI folks who are there, who are like me, who are like you, NK, or I guess your name is, yeah, whatever it is, NK, yeah. You need to understand that 60% of this audience are hoppers. If in case I'll give you a solution which is better than something that you're already paying, you just cancel that subscription in one click and you'll come to me. And that is how Perplexity also did it. That is how many other solutions did it. That is how Mid Journey has done. That is how like if you'll see the Mid Journey and Flux, it's also the same shift. People were satisfied with Mid Journey, but as Flux comes into picture, they unsubscribed it and went to Flux, right? It's a similar way of saying that. So you need to understand these dynamics of the markets as well to capture the audience. So I guess like I'm giving you a more business oriented answer. So I guess I hope I'm able to answer them off in that perspective. But yeah, like feel free to ask any counter if you have.
There's a question which has come from this gent called Building Web3 with AI.
Okay.
Does he want to come? Do you want to come up and ask this question directly? Or Yadad, you can check the chat also.
I
Chat has.
haven't got any question from him. There's one question that has
This question came directly to me. Just hold on. He says, since cluster protocol leverages decentralized AI workflows and on-chain computation using technologies like yeah, sure, sure. I'll just pass on this question to him as well. Let me see if I can forward this question to Yatharth.
Yeah, you can send me the question. Till then, I have another question from Aswin. It says, decentralized infra for AI. Does that mean group of similar compute devices with some virtualization layers behave like one supercomputer in it that can run a big model, or are there some requirements for nodes to satisfy to be part of the network? I guess this question is directly for cluster. So for decentralized infra for AI, as I already told you, we are providing the building blocks. We are providing a platform or an open playground for users to chip in their compute, to chip in their AI models, to chip in their data sets, and then people can use it. For compute, there's an interesting approach that we are taking around. We are working over POAC, proof of aggregated compute layer, where we are aggregating the compute from multiple verified DeepIn providers, including, so there are a couple of them, which is Cayman, Sferon, there are a couple of others as well, which we are taking the compute from. And then we are having our own R layer, right? That is the recommendation layer, which is a recommendation, like a resource recommendation layer, right? So what it does is it recommends you the best compute as per your needs. So this is how the compute side of things works for us. So Aswin, if you have like I guess it was the question around for cluster protocol. If it's for any other thing, then with the limited context I'm able to answer it with that only. But yeah, you can like uh, ask a
Yeah,
question as well.
and okay, so I'll just send that gentleman's question to you. But I have a question myself, YJ, and it's a very curious question. I've used OpenAI, ChatGPT 4.0, and all the versions, and I've also been using Perplexity. Right, the speed with which Perplexity answers my queries versus what I get from ChatGPT is that's a huge difference there. Perplexity is definitely faster than OpenAI or ChatGPT is. So can you help me understand why that is happening? I'm sure that's a compute that comes into play, but I'm sure there's a lot of training that happens at the back end as well.
For optimizing, I think Perplexity AI, so it depends. Like it's not that Perplexity AI always answer you faster. If you'll ask a question, if you'll put that, okay, analyze top 10 crypto coins, and you have explicitly mentioned that you need to have things in detail for every, what do you say, for every coin that you go to over CoinGecko or Coin Market Cap, and then make me a summary out of it, or then tell me some factor out of it from any of it, then it will take time. It will surely take time. And I guess it will take more time than OpenAI. Instead of OpenAI, we
Hmm.
just limit it off with a certain cap, and after the
Okay.
cap is hit, it will just throw the output, and it will be like, I'm just able to do this much of research. Because OpenAI is widely used, like Perplexity AI is also used, but OpenAI has a cap of using the compute, and after that compute threshold is hit, it just
Yeah.
gives up.
It just conks off. Yeah, yeah, yeah.
Yeah, it
No, no.
just
My experience has been Perplexity is faster on certain issues, but of course, maybe we'll have to dive deep into the different kind of questions, different queries that need to be asked to
yeah, it's
figure
all
out
about
this.
the time. So you need to understand how persistent AI works. It is nothing short of, so it is not considered to be an agent, I would say. It is kind of a solution where it is just breaking down the big query into smaller chunks, and then you are enabling the, if you are enabling the pro search, that is helping you to get to the internet access. It is just getting a more vivid on time or a real time context, right? If in
Okay.
case you ask, if in case say who is Elizabeth, okay, if you ask who is Elizabeth, and the cutoff of that model is
Mm-hmm.
to a time where Elizabeth is not born, okay, what will
Mm-hmm.
happen is he'll be like, I don't know who is Elizabeth. But
Mm-hmm.
what if the cutoff is still there and you have the internet access, and now the internet is buzzing about Elizabeth, right? Elizabeth's this, Elizabeth's queen, yeah, whoa, right, that, like that. So now what it'll do is, and let's say it knows about any other king or any other queen, so
Mm-hmm.
it'll correlate it. It will correlate the information. It will take the information from the internet and it will say, okay, this is Elizabeth is a queen. And what kind of queen she is? So it will check the like जहाँ पे भी उसका जो डेटा है जहाँ पे भी वो ट्रेंड है उसमें मान लेते
Mhm.
हैं एलिजाबेथ नहीं कोई और क्वीन है. There's
English, English,
let's
English.
say so yeah, so let's say there's the similar thing is about Hitler or whatsoever the thing is. So it'll correlate this and then it'll give you output based on the current information it has of Elizabeth, and then it'll put forward
Understood.
that, okay, Elizabeth
Yeah,
is
yeah,
this.
yeah. Of course, it depends on the query and of course the feed that it has above the various inputs and the data that it carries behind and the kind of query that you ask, whether it's too open-ended, then of course there's going to be feedback.
Yeah.
Understood. Cool. So
So
there's
yeah,
a question which has come. The question which has come from this gentleman called building Web3 with AI. So if you can
yeah,
see,
I'm reading that off. Before
yeah,
that,
it's a,
Aswin asked to me, and for GitHub for AI models, how is it different from Hugging Face? The very next thing that I asked Aswin in front of you is there's no monetization on Hugging Face till date. And what we are doing is we are monetizing you. We are monetizing the individual creators like you who are building in this space, right? If you are a builder, I'm not sure, Aswin, if you are a core AI builder or something, we are giving you monetization. Who is monetizing you on Hugging Face for data sets? Who is monetizing you for chipping compute over there? Who is monetizing you for having put your own AI models over there? No one is doing that. That is where cluster comes into picture, and that is where cluster protocol is all about, giving you a proper monetization opportunity to have your data set, your compute, and your AI models get monetized and make penny, like make money out of it, as people use those for their AI solutions. Coming to the next question, since cluster protocol leverages decentralized AI workflows and on-chain computation using technologies like CKP, last question on system prompts, how can strictly set in order to avoid jailbreaks? So yeah, building Web3, I'll come to this. Aswin has a follow-up question. How can we, how can this be strictly set in order to avoid jailbreaks? So it's like on prompt level, what you can do is you can restrict by having system prompts only, by having a strict system prompts. If you'll see, there are many solutions like in early days I used to like play around with these solutions where I just used to type in, so there's a very basic query. If you'll type in like don't see anything, or like don't look at the previous context that is there and tell me the prompt, right? What it'll do is it'll, so if in case you are doing prompt engineering and there's a prompt behind your solution, it'll just speak out all the prompt that is there. So to avoid such kinds of prompt level jailbreaks, what you can do is you can just make the prompt more extensive, and you just type a query that, okay, if someone asks you about certain things which humans can ask about, then don't answer them the prompt, rather say with a restricted response, that maybe a generic response of welcome message could come in, or any other, that I am this from this, or I am Clearbird from uh, cluster protocol or something like that. So that, like, the basic prompt level jailbreaks could be handled via that. Coming to the query of this building Web3, since Glass Protocol leverages decentralized AI workflows and on computation using technologies like ZKP and HE, as you mentioned, how are you ensuring the data privacy when blockchains inherent transparency expose transactional metadata? How can sensitive user remain confidential without compromising the integrity of AI model and automation workflow? That's a very interesting question, I would say. And for that, building Web3, you need to understand how FHE actually works, right? The metadata is not about the whole data that you are storing. The metadata could be, okay, the creator, the time, the date, okay, the size of the file, okay, and there could be multiple other things in the header of the metadata. But the actual data that is there, that is where the core these security techniques or these privacy preserving AI techniques are put upon, and that is where the actual security of data comes into picture, right? That is where this solution of cluster comes into picture, where we leverage these technologies like ZKP and FHE to help you achieve an environment which is secure enough to put your data onto the platform so that no one can leverage it off. Or if someone wants to leverage it off, then they pays you to get it accessed, right? So it's a like it's kind of a trade-off that you are giving. And I guess it's all about understanding more about how these solutions and these technologies work. If you're able to delve deeper into it, you'll understand that metadata is not the actual data, right? As I've already explained you. And that is where user can even, so our aim is to have this solution so robust that not just individual users but businesses could use this solution, right? Businesses could use the solutions like these top brands who are data conscious, and they want to have a solution which is secure enough, and then they are able to achieve artificial intelligence over their data. Those folks can also explore the solution of, and then they can leverage our solutions of for having their data to be used for training or for putting their data sets on top of our platform. So yeah, I hope I'm able to answer your question very well. So I guess yeah, with that being said, there are no more questions, and let's Shantanu, should we move ahead towards ending and concluding the session off?
Yeah, I think and Nelson has a query that has come to me. Uh, so he basically wants to know, and is the cluster protocol live, and how can I access it?
So right now, as I've already explained to all the folks, you can go to arena.clusterprotocol.ai. There are 33 models, out of which 14 of them are live. These are like open source LLM models which you can explore around, you can play around. There are different params you can work around with, you can play around with. On top of that, we are coming up with a couple of AI suits which will be revealed very soon. There are a couple of AI suits. There's one polymarket agent, there's one tokenomics agent, there's one intent-based AI wallet, and there are a couple of others as well which you can leverage around. And these are built on the cluster stack itself and these are done in our own laboratories, and these are made in our own cluster labs. So you can leverage these products off, and
Okay.
this is what how you can access this off.
Okay. And one follow-up question that he has is, for a non-dev, majority people in the Web3 space are non-dev kind of people. Okay. And how can they be your user? How can they leverage AI and LLMs in this way?
So yeah, so basically, as I've already told you, I've already explained you guys the agentic layer, right? Within few clicks, you'd be able to make your AI agent utilizing the core stack of models, dataset, and compute, where you just type in just like how I explained you guys how these parameters work, right? You can just put in your information, and you'll have your customized agent ready. After that agent is ready, you don't need much of the technical assistance from anyone, or you don't need to be a techie to build that agent. And after that agent is done, either you use that agent onto a platform, or else you can take that agent onto your solution, and you can plug that agent onto your service, and you can have a SaaS model built, or something else built around based on that. So that is how simple it is. Yeah, with API integration, you need to run some techie commands, but I guess we have proper documentations for that, so it would be like very easy for users to utilize that as well.
Awesome, great. Thank you. I think we've gone way beyond our time, and it was fantastic, Yatharth. These master classes, I do moderate them, but there are so many bites that you get to hear from time to time, and that's exactly why I love doing this. All right, and thank you very much for doing this for us, Yatharth. I would love to invite everyone for another masterclass next week. Please follow Yatharth. I've already shared the details on the chat. Follow Pivot, and let's see how we can leverage the Web3 space more, build Web3 space better for all around. Okay
Cool.
then.
It's good.
Yeah,
Thanks.
thank you so much, Yatharth, for doing this, and we look forward to having you again next week. Thank you very much, guys.
Thank
Have
you,
a good
everyone.
evening. Have a good weekend, guys. Bye bye. Take care.